Hello, I am Siddharth Pendharkar from Pendharkar's Institute. For more videos on physics, chemistry, mathematics, kindly download Pendharkar's Coaching Institute app. You will find the PCM videos in the store on Pendharkar's Coaching Institute app under Performance Booster Pack 1 or other chapter-wise courses. Coming back, let us try to understand principle of potentiometer. So potentiometer wire is this wire AB. It is a very long wire fit on a wooden board, and here is a cell whose EMF is epsilon or E and whose internal resistance is small r. Let capital R be the resistance of wire AB. Let capital L be the length of wire AB. And now, what is the principle on which potentiometer works? I have to derive it, but to summarize it, simply put in a nutshell, if I consider any 2 points on the potentiometer wire, the PD, potential difference between the 2 points, is directly proportional to length of the wire between the 2 points. Please see, if these 2 points are some distance apart, there is some potential difference. If the distance doubles between points A and C, instead of 2 centimeter, it is 4 centimeter. Then if the PD between them were 3 volt, it would become 6 volt. So as distance doubles, PD doubles between them. If distance triples, potential difference between them triples. PD between any 2 points on the wire is directly proportional to length of the wire between the 2 points. Now let us see its proof. You will get a question saying derive principle of potentiometer or explain principle of potentiometer. So you should not just say that the PD between 2 points is directly proportional to length of the wire between the 2 points. You should also derive the condition. Now let us see the derivation. Firstly, some terms, as I mentioned, capital L equal to length of wire AB. This length of wire AB, it is capital L. Capital R is the resistance of wire AB. Capital A is area of cross section of the potentiometer wire AB. The EMF of the cell is epsilon, or you can write it as E. Small r is the internal resistance of the cell, as shown in the figure here. And now let's continue. Current through potentiometer wire AB. Now current equal to EMF upon total resistance. So I, current, equal to EMF epsilon upon total resistance is external plus internal. So total resistance will be resistance of wire AB, which is capital R, plus internal resistance of the cell, which is small r. And then please see, uh, next, potential difference across wire AB. Just give me a minute. Potential difference across wire AB. Now, when I'm talking of potential difference, I should consider only external resistance. On the other hand, when I'm talking of EMF, I should consider external plus internal resistance. So PD across AB, potential difference across AB is V equal to IR, R capital R, only the external resistance of the wire. So VAB equal to, instead of I will write epsilon upon capital R plus small r, epsilon upon capital R plus small r into capital R. This is the expression for potential difference across total wire AB. I'll divide both sides by total length L. I get something like this. VAB upon capital L equal to epsilon capital R upon L into small r plus capital R. Now VAB upon L will remain constant as long as the right side remains constant. Now in the right side, what all are the terms? First, capital L, length of wire AB, that's going to be more or less a constant. Capital R, resistance of wire AB at a given temperature, it's going to be a constant. Small r, internal resistance of cell, again that's going to be a constant at a particular temperature. And epsilon, or the EMF. Now EMF of the cell, as long as it remains constant, the right side of this expression remains constant, and potential difference across wire AB divided by length of wire AB remains constant. So VAB upon L is a constant, and it is called potential gradient, change in potential with length, potential gradient of wire AB. So what is potential gradient actually? Potential gradient is potential difference per unit length of the wire. Gradient is change in something. Temperature gradient between Mumbai and Pune would be change in temperature with distance as one travels from Mumbai to Pune or Pune to Mumbai. Variation of temperature with distance would be temperature gradient. Here we are talking about potential gradient. And this potential gradient VAB upon L is a constant, so we'll call it as K. So, you know, VAB upon L is equal to K. All the right side is a constant. And then if I'm writing VAB equal to K times capital L, look at this further. What if I don't consider AB, I consider A and some other point C, some point C, which is at a distance small l from capital A. So on the same lines, potential difference across AC will be K times small l. What did we establish here? VAB, potential difference across AB is equal to K times capital L. Similarly, potential difference across AC will be K times small l. K is a constant, so potential difference across AC will be proportional to small l, the length of the wire between A and C. In short, what we have proven is potential difference between 2 points A and C is directly proportional to length of the wire L between A and C. As the length of this wire keeps on changing, proportionately the PD across AC will change. So that is the principle of potentiometer, that PD between any 2 points on the wire is directly proportional to length of the wire between them. Now there are some assumptions. So all this is valid provided first, wire is of uniform cross section, second, current through the wire is the same, and third, temperature of wire remains constant.